Okay, this is my first attempt at a tutorial on variable length subnet masks for the Cisco CCNA and understanding subnetting when it's a variable length subnet mask. So I'm going to try to explain this and we'll see if it works out. Um, I've got a situation here that I've just drawn up where you've got three routers here. The little circles are routers. Okay, there's a router, there's a router, there's a router. And then there's a bunch of networks. So this router is connected to this router, and that connection from router to router is a network. From this router to this router, this connection is a network in between these two routers. In between these two routers, that's another network. So you've got the three networks in between the routers. Then this router over here, this top left router, has a network connected to its, let's say, another interface, and that's another network over here. Then this router has another interface connected to a network over here. And then the bottom router actually has, if you count all its interfaces, this bottom router has 1, 2, 3, 4 connections. It has 2 extra connections to a network here and here. So just take a look at the picture first of all. See, the top two routers have a total of 3 interfaces. The bottom router has 4 interfaces. And total networks is 1, 2, 3, 4, 5, 6, 7 networks. Okay, so I've got 7 networks. So if I was going to say, okay, you've bought the 192.168. This is just an example. It's a private address, so it's not a real example, real world example. But let's say you have the 192.168.1 address space, okay? That's you. You're the one network, right? 192.168.1. You own that, right? And so you need to subnet it. You need to subnet it into 7 networks, right? Well, how would you do that? Okay, well, first of all, the way you learn at the beginning of the Cisco curriculum is to divide it into just 7 networks classfully. So what you do is you say, you say, okay, I'm going to, or not classfully, but not with, I wouldn't say classfully, but with the same size subnet for each network. So you're going to divide this 192.168.1 network into 7 equal-sized networks. And to do that, you take the classful subnet mask of 255.255.255.0 and you borrow bits from the last octet, the 0 octet. So I've drawn an arrow going from the 0, the 4th octet. We count from left to right always. 1, 2, 3, 4, 4th octet, the 0 here, and we're going to borrow some bits from it. So we'll borrow 1 bit, 2 bits, and 3 bits. 1, 2, 3, 4, 5. 8 bits total in the octet, so I borrowed 1, 2, 3 bits, right? And that's going to change this from a 0 to a 224, okay? And the network bits that were borrowed were 1, 2, 3 ones, meaning 3 network bits, so that's 2 times 2 times 2, 2 to the 3rd power, meaning 8 subnets, okay? What's the magic number? The magic number, 128-bit, 64-bit, 32-bit. The third one is in the 32's place, counting from left to right, if you count it in binary. This is the 128's place, 64, 32, 16, 8, 4, 2, and 1. So this 1 bit is in the 32. So the networks would be, you could do the networks like this. You could say, I've got the 0 network /27, okay? Why? 8 bits, 16 bits, 24 bits. We borrowed 3 bits, 25, 26, 27. So basically, if I was to fill in all the networks, it would look like this. This is the 32 network /27. This is the 64 network /27, right? And you could just increment them up by 32 each time. That's going to be your networks. 96 network /27. Hopefully you can see this in the video. This would be the 128 network /27. Okay, and then you're going to need After that, add 32 to the 128 and you get the 160 network / 27 and the 192 network / 27. Okay, so that's essentially what you would have. All right, if you were to divide the network up into 7 networks by changing it to a 255, 255, 255, 224 network. I borrowed 3 bits. The ones are the network portion, the zeros are the host portion. I borrowed 3 bits, 2 to the 3rd power is 8, so I can have 8 networks, each of size 32. How do I know that? Well, the magic number, the last bit I borrowed, is in the 32's place, so the networks go up by 32. The 0 network, 32, 64, 96, 128, 160, and 192. Now, in the CCNA, they'll say to you, well, wait a minute. What if we want a network, but you want different sizes in the network, right? So in this network over here, you need more than 32 hosts. See, right now, the way this works is I've got 7 networks, right? Let me get my little tool here. I've got 7 networks. 7 networks, right? Out of 8 networks possible, right? Each network is maximum 32 hosts, which is actually 30 hosts because you can't use the first address or the last, because the first is the network address, the last is the broadcast address. So essentially what you have right now in this scenario, 7 networks out of 8 networks possible, each network is a maximum of 32 hosts. But what if you need different size networks? What if you want this network to have 128 hosts? And then these networks in between the routers, these are just point-to-point links in between the router, directly connected from one router to the next. You only need 2 hosts, 2 usable hosts to go in between these networks, right? You don't need 32 host addresses, right? This network over here, let's say you want 32 hosts. This network, you also want 32 hosts. But this network over here, you've only got 10 computers, so you only need 16 hosts. So in the next example, I'm going to show you how you would change the subnetting scheme so that instead of having /27 on all these networks, right, and having 8 networks of size 32 hosts, right, each one /27, you could have different subnet masks, different lengths of subnet masks based on the needs on how you want to divide up your network. And I'll do that in the next example.